But there is a problem. These 4 orbitals are not identical. The 2s orbital is spherical, while the 3 to p orbitals are dumbbell-shaped and point along the x, y, and z axis, 90 degrees apart. If carbon bonded using these directly, its 4 bonds would be unequal. Yet experiment shows all 4 CH bonds in methane are exactly the same. Nature's solution is to mix them. When one s orbital mixes with 3 p orbitals, they form 4 brand new, identical orbitals called sp3 hybrids. Each has one large lobe, and the 4 large lobes spread as far apart as possible, pointing to the corners of a tetrahedron with bond angles of 109.5 degrees. Put a hydrogen on each lobe and you get methane. The same sp3 carbon builds ethane and the giant network of diamond. 4 single bonds always mean sp3. Now mix one s with only 2 p orbitals. You get 3 sp2 hybrids lying in a flat plane, 120 degrees apart, and 1 p orbital is left unhybridized, standing perpendicular to that plane. In ethene, the 3 sp2 hybrids form the flat sigma framework, while the 2 leftover p orbitals overlap side by side to make a pi bond. Together they are the carbon-carbon double bond. sp2 means trigonal planar, 120 degrees. Finally, mix one s with just 1 p. You get 2 sp hybrids pointing in exactly opposite directions, 180 degrees apart, and 2 p orbitals are left unhybridized. In ethine, the sp hybrids build a linear skeleton, while the 2 pairs of leftover p orbitals form 2 pi bonds at right angles. That is the carbon-carbon triple bond. sp means linear, 180 degrees. Carbon is the backbone of millions of compounds, and it almost always forms exactly 4 bonds. But why 4? And why does a methane molecule point those 4 bonds into the corners of a tetrahedron instead of a flat cross? The answer is hybridization. Let's build it in 3D. Carbon has atomic number 6. Its ground state configuration is 1s2, 2s2, 2p2. Look closely, that leaves only 2 unpaired electrons in the 2p orbitals, which would predict just 2 bonds. But carbon is tetravalent. To explain this, 1 electron from the filled 2s orbital is promoted to the empty 2p orbital. Now there are 4 unpaired electrons, 1 in 2s and 3 in 2p ready to form 4 bonds. Let's put it together. sp3 gives 4 bonds, tetrahedral, 109.5 degrees, like methane. sp2 gives 3 bonds, trigonal planar, 120 degrees, like ethene. And sp gives 2 bonds, linear, 180 degrees, like ethine. Same carbon, 3 different shapes, decided entirely by hybridization. 2 quick exam tips. First, to find hybridization fast, count the steric number sigma bonds plus lone pairs. 4 means sp3, 3 means sp2, 2 means sp. Second, more s character means a larger bond angle and a shorter, stronger bond. That's why sp at 50% s character opens all the way to 180 degrees. If this made hybridization click, please like and subscribe. And for more chemistry concepts explained in 3D, keep watching Magpie Hub.